do we do first? What do we do first, Darren? We can place it in exponential form, and before that? Okay, so before then, we would let it equal x first, then we can place it in exponential form. So we just want to let it equal x first, and then if we put it into exponential form, Darren, what would it look like?
2 to the x equals 64.
Right, 2 to the x equals 64. Okay, what's our next step here? Does anyone know what our, oh, Leanna. Okay, so with the knowledge of your multiples, Leanna is saying that 2 to the 6 is actually equal to 2 to the x. The reason she knows this is that 2 to the 6 is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 6, or 2, which is 64. So this is just a knowledge of your multiples, so you just know that 2, 4, 8, 16, 32, 64, 128, 256, 512. All of those are multiples of 2. So it keeps going, but you know, 1024, 2000, anyways. So part of this is that if you have that knowledge, you could do it this way because it's just a lot easier. And then what's our last thing that we do here? What's the last thing we do here? Okay. Right, x equals 6. So the bases are the same, and the exponents should be the same. So if we don't know what x equals, well, it just equals the same thing, which is 6 equals x. Right, because it just, the exponents should be the same. If we know that both sides are equal because of the equal sign, then we know that x equals 6. So a question might be evaluate the expression log base 2 of 64, and then you could solve it this way. Okay, so for the second method, I will say that it is, let's see, we have, it's actually going to start right here. So it's going to be that 64 is equal to 2 to the x power. So the first few steps are the same, but then you would start here. So what would our next step be at this point? What would our next step be at this point? And again, this is the different way of solving this. Okay, and just as a reminder, you can take the ln or you can take the natural log. Both will give you the same answer. But in this case, we're going to take the natural log. But again, if you choose to use log, you will still get the same answer. Okay. Okay, so what does that do to both sides? Or what? How does that help us here? There.
ln and 2 to the x is equal to x times ln 2.
Okay, so if there's an exponent, you could just go ahead and bring it to the front. If you look at your rules, that's one of the rules that you've written down in your notes, is that if you're taking the natural log of something or the natural log or log of something, the rule is that the exponent can now be brought to the front, right? To the front of, and it's now multiplying. Okay, so what's our next step here? What's our next step here? Nathan? Divide both sides by ln2. The reason we're doing this is because we're solving for x, so we're isolating everything from x. We're pushing everything away from x, right? Because we want to just have x by itself. So then we get ln of 64 divided by ln of 2. You can evaluate this in your calculator, so just type in ln 64. We already know what the answer is, but you can just do it for practice. And then you get is equal to 6. So we get the same answer as our left, and you can see that we have the same answer. Oops. So again, this right method is more helpful for evaluating numbers where you know the left is not a multiple. They're not a multiple of each other. So if 2 is not a multiple of 64, meaning that 2 doesn't divide into 64, then it's very helpful to use the one on the right. Okay, I'm going to do one more example, and then you guys can grab a Chromebook, and then you can work. Okay, so the last problem we're going to do is, does anyone still need this one? No? Okay. The last one we're going to do, I think it's a pretty fun one, is log of 25, 1 to the 25th power. Oops. Let's see. So this one is log base 25 of 1 over 125. So in this way, there are actually still two methods to do this. So what would our first step be here? Can anyone remind me of our first step? Sami? Equal to x, awesome. And then Nathan, what's our next step here? Exponential form. So we're going to move this 25 over here. We get 25 to the x power. Okay, so we're going to solve this the first way. It is a little bit more complicated, but it is still the same. Okay, can anyone help me out here? How would I solve this using the first method? What would I do next? Does anyone know what I would do next? So I want you to think about, does 25, does that ring any bells of what number goes into 25? And can we change that form? What is 25? Same thing for 1 over 125. It should look pretty familiar. Should ring some bells here. Okay, so as a hint, what number typically goes into a number that ends with a 5? Right, 5. So 25 must be some multiple of 5. Well, what times what equals 25? 5 times 5. So we can actually change this into 5 to the second power, 5 to the 2x, I believe. Negative 2. And then 1 over 125, what is that a multiple of? How many 5s is that?
1 over 5 to the third.
Yes, or? So it's either 1 over 5 to the third, or it's 5 to the negative 3 power. So this would be 5 to the negative 3 power. Oh, what the heck? Sure. Thank you. Okay, so it's either 1/5 to the third power, but we want them to have the same base. So the reason I change it to 5 to the negative 3 is because, again, negative means that you flip it to the reciprocal, which is 1/5, and then I multiply by 1/5 times 1/5 times 1/5, which is 125, and then, or sorry, 1 divided by 25, and then 1 divided by 125. which is right here. So now that we have the same base, and we know that both of these are equal, what can we do now? So now that we know that these have the same base, and we know that the exponents are equal, what can we do now?
You can just solve for the exponents by doing 2x equals -3.
Yeah, thank you. So we could do, well, we know that they're equal, so we could just set the exponents equal to each other. Now we can solve for the exponents, and now all we have to do is divide by 2 on both sides, and we get x is equal to -3/2. So you could even test this. You could go ahead and put in your calculator. You could say, well, 25 to the -3/2, and you can get 0.008, or you could do 1 divided by 125, and you can see that we get exactly the same answer. So there is our answer. We've evaluated it correctly. Okay, so for this one, if you didn't know that 1 divided by 125 is 5 to the -3, you had no idea that 25 is 5 squared, we can do a different method, right? We can do a different method. So, from here, you could evaluate 125 is equal to 25 x. And then what could we do to both sides?
Use ln on both sides.
Right, we could use ln or the natural log, or sorry, that is natural log. We could use natural log or we could use ln. And then since we're taking the natural log of both sides, what can we do to the right-hand side? So in this case, we take the natural log of 25, so that what can we do here? Okay.
Just move the x over, so it's x times ln.
Right, so by the properties of natural log, you can move the x in front. And now what could we do now? What's our next step here? What would our next step be here? Nathan? Right, we would divide both sides by ln 25. You could evaluate this in your calculator, and you should get the same answer. You could do natural log of 1 divided by 125. And you get your answer on your calculator says -1.5, which is the same as -3/2. Okay, so you get the answer of -1.5 or -3/2. So it's really up to you which way you want to evaluate these questions. Both of these are, again, there's different strengths to both of them. One of them, again, you can trust in your calculator. The other ones you can just trust in your speed. But now you guys can go ahead and use Delta Math either on your phones or on the computer.